We have a fellow says, he says, physics and measurement go together like bread and butter. Measuring objects puts them in their place accurately.
We got a stamp collector.
Yeah. He says measurement is science. So if you measure a table like that little fellow there is doing, he says you're a scientist. Okay, so he says that measurement is science. And yeah, that's when we bring the dough roller.
What did he say? Get the fucking.
We educate them the right way. We learn them. Okay, we learn them. Okay, so here we have a little bit of some answers. What some of the things that physics does not do. These are not activities of physics. Okay, so in case you use any of these activities, you do some of these activities, you think these belong to physics, here we correct you. Okay, we learn you properly. Okay, so here he is. We have observe. We do not observe. We do not gawk. Okay, which is what all these people are doing on the right. Okay, we do not do experiments. We don't do experiments in science. Yeah, you heard it right. Let me repeat it because some people say, well, he must have misspoken. No, we do not do experiments in science. Anyone can do an experiment, not learn anything from it, and he thinks he's a scientist. That's not the way it works.
I'd say it differently. I'd say these are part of science, but it's not the crucial part of science.
Okay,
they're like a preamble to science.
Yeah, we're saying well, the way I like to put it is this way. This is the way I put it. There's the detective and there's the prosecutor. Okay, now they have two different jobs. Okay, the prosecutor is the person who says you're innocent until proven guilty. Okay, and he goes through the motions of explaining why he thinks you're guilty. The detective works exactly in the opposite direction. He says you're not off the hook until we can verify your alibi. Until then, you are a suspect. You are considered a suspect still. Okay, so they work exactly in opposite ways. Meaning, the detective goes out and does all his job. He looks for evidence, fingerprints, whatever he found out there, the gun, etc. Right? He gives all that to the prosecutor. He is not a scientist. He did the investigation. He did all the hard work. He is not a scientist. The scientist is the prosecutor, the guy who has to explain it at the conference. Yeah, he's got to make sense of it and present it to the jury. In this case, present it to in the conference. He says, "This is how the universe works." For example,
you're basically saying anyone can ask the question, but to answer it, because anyone can drop the pen, but to explain why it drops, that's the science part.
That's one issue. The other one is research is not science. Okay, research is not science. You can research all you want. It doesn't mean you came up with something. It's the guy who presents it and says, let me explain it to you. That's the scientist. But to do research and not make any progress, not have learned anything, so what you did research? So what have you studied? So what have you observed? So what if you did experiments and did not learn anything? That's the detective. Okay?
I'd still say it's part of science because it's the whole process. I add that to the process, but it's not the crucial part. If you just do that, you're not doing science.
We chop it off here.
Yeah, if you want to go clean, if you want to make it as clean as possible.
Here we say only the prosecutor, the guy who presents a theory, is a scientist. That's the only guy that's a scientist. The other guy who did all the hard work, he's not a scientist. He's just a lab worker.
You're the gopher.
He's a gopher.
Hey, bellboy.
Okay, yeah.
Do the work. I'll put it together.
So I just want you to know what we say here, okay? Anyways, none of these collect data, devise equations, predict, making predictions. That's called an astrologer, okay? That's not a scientist. We don't present evidence, okay?
We assume.
Not in the case of prosecutors. You know, in the regular law, people present evidence. In science, we don't. We just explain without evidence because evidence is used to persuade, and we do not persuade in science because that has to do with religion, with convincing you, with twisting your arm, okay? We do not test theories. We don't verify or falsify theories. We never fake anything. No falsifying in science, okay? We don't prove, we don't know. Knowledge has nothing to do with science. Okay, we don't believe, we explain. We don't persuade, convince, convert, or recruit. We don't invent. Technology has nothing to do with science. We don't form clubs, associations, groups with other people. I mean, you can if you want. Congregations, that's got to do with religion.
Well, just because you do it doesn't mean you are a scientist. The other way
right, and that's my point. And then we do not give prizes. Okay, so none of those have anything to do with being a scientist or a physicist. And one step further now, we move one step further and we say science does not use any of these terms. Okay? We do not use the word force. We do not use the word field, energy, mass, time, none of those words.
I got a caveat, without defining it rigorously.
No, even if you define it rigorously, because none of those words can be defined rigorously.
That's your assumption.
No, that's my knowledge. I know for a fact.
On deck.
Okay, none of those words belong in science. Why? Because let me tell you what the origin of those words are. The reason you learned all these words, probably in high school, probably in college, okay, is because the mathematicians put them in your head. Okay, they shoved them into your nose holes and
ear holes.
Shove them into your nose holes, and what happened with that is that you memorize them, and now you move these things around. The problem here is that you treat them as physical objects. And as the subject of today will be, these are all concepts, and you cannot treat a concept as an object. That's where the problem is. Okay, so if you use any of these terms, we will use our dough roller on you. Okay, you can't make your case with any of these words. Okay, that's where it starts. Okay, and you will find a couple words there. One is ether at the bottom left there, and electricity in the top middle there. Okay, ether and electricity are not physical objects. And people say electricity moves, current moves, runs, whatever flows. You can't use that language in science. And no, this is not semantics. Okay, people say, Bill, you're doing semantics, you're doing word wizardry. We're trying to teach you how to talk in physics. Okay, and it's very hard because you learn something different in high school and college. And so you're so used to saying the current flows. That's like saying the river flows. Now, the river already is flowing because river means water that flows. So you can't say the water that flows, flows. That's what you're saying when you say the river flows. And when you say electricity flows or current flows, you're saying current is what? What is current? Current is, if you go with the official, the mainstream, it's electron. It's the motion of electrons from one atom to another. That's what it is, if that's what you believe. You might have a different version. Okay, no problem. But in general, people think of current as the flow of electron beads from one atom to another. The electron bead is the object, a little ball there. That's what you got to think of it as. And it's flowing. It's going from one atom to another. That flow is called electricity. You cannot say electricity flows or current flows. You can say the electron flows, not that the electron flow is flowing.
Yeah, you can't say the movement is moving.
So we're trying to teach you how to talk, and people don't like to be taught how to talk because they say, I've been saying current flows for years. Yeah, because that's what they taught you in high school.
Well, I think the way you just laid it out is more convincing, or more. It's clearer for the listener than just saying, don't use these words. It's better to explain, look, what are you saying right now? Yeah. You're saying that the motion moved.
Yeah.
What does that mean?
You're saying that the electron flows.
Yeah. The electron can flow faster, maybe, or change direction.
Yeah, but that's not what they're saying.
Yeah.
They get into that bad habit, and what you're doing is using words of mathematical physics. Why? Because math is math, physics is physics. None of those words that you just saw belong to math. Math deals with numbers and with operations on numbers, right? That's math. And what they did, they said, well, how do we apply this? How do we make any sense of the world if we don't introduce math into that world and measure and analyze it mathematically? And that's where we have this religion known as mathematical physics came into being, and they had to create words to be able to give some physical interpretations to the equations. That's when they created the word force, the word mass, the word energy, all these irrational terms, which are not only undefined, but even if you were to define them perfectly, they wouldn't make any sense.
Their notions are nounified verbs.
Yeah, because they concretize them, or however you say that.
Like force. Force is a good one, where it's like, force already implies motion, but when you say the force moved something, no, the thing that moves something moves something. Force is just a concept that we use to explain that.
Yeah, because all you said is pushed it. That's all you said, or pulled it. You can't say that. You got to say, what is the physical object that did the pushing? Then you can talk about force. And then you don't need force at all, because now you mentioned the hand and the box, and you said, my hand pushed the box. We're done. We don't need the word force. But when you say a force came up against the box, now it means you drank too many beers. Okay?
I mean, I keep telling you, I think robots and programs could do better physics than most people, because if you have to define everything so rigorously, they would find all the kinks in the theory.
I think some of the programmers up there might understand that argument. Okay, so here's one fellow, and he uses ether, and he says, there's nothing irrational about the ether. It's nothing mystical. It's a fluid. Okay, you mean like water, it's, and what is water? Well, water is, it's a fluid, just a bunch of atoms, right? It's a fluid. He says, ether is only irrational if you believe it's made of particles. Okay. Well, what is a fluid made out of? I mean, if it's
atoms, not particles. Come on.
yeah, a fluid is made.
What do you think an ether is? Like, what are you, dumb or something?
Yeah, what do you think the ether is? Well, the ether, you got to tell me, first of all, because you're introducing ether. But there you have the ether. It's a bunch of particles, and that's what they say. Well, there's two versions. One version is that the ether is space. Space and ether are synonyms. They're identical. Mm-hmm. And another one is that ether is within space. Okay, those are the two versions that are out there. And so the question here, in that case that you see there, you see all these little dots. That's the ether. The black stuff is space. So it's ether within space. Yeah. And what is moving there could be one of two. It's either a wave moving through the ether, or it's the ether itself, which is vibrating. And we have all these versions out there of what the ether is and what a wave is and all that stuff. Okay, so you have to be very specific about what it is that you're moving. The physical object is absolutely crucial. You need to identify it.
Well, it's also the base assumption from which you explain things. So the properties of it have to be rigorously defined so that we can get all of the because when you make an assumption, especially a base one, you get a lot of resulting, I guess, like logic from it. Like, for example, yours, when you say all atoms are connected by ropes, that's an assumption. We don't know this. We're just assuming it. But once you assume that, when you follow that line of logic, you get all these tangents of what that means. And it's the same thing here. You have to really rigorously define that assumption, because if you just change a little bit of it, you're going to get way different. It's like in a golf swing.
That's one issue. But the other issue is that you have to identify the object, and there's only one way to identify the object, is put it in front of our eyes so we know what you're referring to when you say ether. So you have to point to it and say, look, this is the ether, if you're going to treat it as a physical object, if you're going to vibrate it, okay? And there's a difference between vibrating all the ether in the universe, as one block, as a single thing, okay? And vibrating a teeny region of the ether and saying, well, a wave is the vibration of the ether. No, if you're going to vibrate the ether, it's the whole thing. If you're going to use a little portion of the ether, you better call it something else. That's not the ether. The palm is not the same thing as the hand. Palm is a region of the hand. If you're going to use a region of the ether, and you can't say the ether vibrates, and that's what light is, the vibration of the ether. No, but if you're vibrating the ether, you're vibrating the entire universe as a single thing. That's the ether.
If the ether is the collection of all these regions, you could say, then vibrating the ether would mean vibrating the collection of all the regions.
Yeah, you gotta separate the ether
it's just logic. You just apply rigorous logic to everyone's words, and then things fall apart real quick.
A lot of these people are not logical. That's the problem.
Well, I don't think they get to the bottom of what they're saying. What they themselves are saying.
And here you have a definition of the ether. Two definitions. One is from the dictionary. Upper regions of space. The Greeks essentially called it ether, which I think means air. It was the God's air. Okay, the air that was outside the earth that they couldn't touch or see. Okay, that was the ether. It's a special type of air. And what is the air? Made out of particles. Okay, made out of units.
I mean special air, not your peasant air. Mount Olympus air.
And then the other one at the bottom, postulated medium for the propagation of light. And again, either the ether is what is vibrating, or the light is passing through the ether. It's the medium through which this whatever light is passes through.
So light is either being carried by the ether, or it is the ether's perturbation.
So you got to identify which of the two it is. Is light the vibration of the ether, which is what the 19th centuries believed, or is light something else separate from the ether that goes through the ether as if like a fish through the water?
But I guess, but along the same lines, it kind of also applies to the black hole and these kind of things, where there's so many versions of it, you can't just criticize it because, like, that's not the one I was talking about. So they give you the runaround. Not that one. You're thinking of someone else's black hole, not my ether. And shit.
So when in doubt, what we do is we go to the sources. And the original source were the...
but there's many sources.
No, that's what I'm saying. The original source, you could say, is the Greeks, which also inherited that probably from the East somewhere. I don't think the Greeks were the originators. But they used that same concept, the notion of the ether, and it was resuscitated more or less by Descartes. Okay, René Descartes, and this is what he had to say about the ether.
What's with the ugly cartoon?
Yeah, space is a plenum, okay? And he says, and what is a plenum? Well, it's a space or all space, every part of which is full of matter. Okay, so again, we're talking about a bunch of particles. That was his notion. He said, what fills space is the ether. Okay, and then you see that other paragraph there, and all this comes from Edmund Whittaker, who wrote a history of the theories of the ether. And this is a statement taken from René. Okay, it says the vehicle of light is composed of a closely packed assemblage of what? Globules, spherical particles, whose size is very small compared to the bodies we see on Earth. So what are we talking about? Little particles. That's what the ether is. It's comprised of all these little particles. The globules are pressed in contact with each other and move outwards. It is the transmission of this pressure which constitutes light. So in the case of Mr. Descartes, he thought that light was itself the vibration of the ether, and that's what all the 19th centuries also who came later, right, also believed. They always thought that light itself was the vibration of the ether. But again, it's a wrong notion, because if the ether is what fills all of space, you cannot say that vibration of the ether is light, because you got to look at the whole object. The object is the whole shebang.
Well,
you can't
that line,
pull a little bit out of it and say it's a vibration of the ether. No, it's a vibration of a bunch of particles that constitute the ether. Then you can say that, but not that the ether is vibrating.
You kind of have the similar situation where when you're explaining light with the rope hypothesis, you just take a chunk of the whole.
And I call that a rope.
I call it a rope. Yeah, but
I don't call it a thread.
You, in the end, I guess, are taking a chunk of the entire.
I absolutely I am. But when you say rope, I'm referring only what's between two atoms. I'm saying this is light. So, but you can't do that with the ether. You can't say, well, the ether is everything, and it's also the little thing that I'm going to vibrate. You can't do that. It
just confuses people.
Yeah, and that's where the problem is with all these people. Well, just in case we have some reinforcement here, we have these people. Robert Boyle. The ether consists of subtle particles. Huygens, he said, ether is constituted of particles. Newton, ether is made up of numerous small particles. And Johann Bernoulli, ether is comprised of excessively small whirlpools. All these people thought of the ether as a bunch of particles. That's the notion they had of the ether. Okay, and again, some of them said it fills space. Most of them had that notion. Others equate it with space and say space and ether are the same thing. It's like the backdrop to every little thing that we have here on Earth or in the universe. But the problem there is that space is considered to be infinite, meaning the ether is infinite. And there's a difference between, an object, a thing like an ocean, right? And something which is infinite, which is not a something at all. If it's infinite, it's the opposite of an object. Object is that which is finite, okay? And infinite means that it's not an object, still growing, or you haven't conceptualized it properly. You can't see the edges of it, the surface, whatever. It's not an object. So if you're going to treat the ether as an object, I want you to draw it. Okay, you got to put a picture in front of it.
But then you also have to explain what encapsulates it.
Yeah, and we'll get to that in a second here. In fact, here it is, okay? See, all these objects are finite, okay? And here you have the solid, okay? You have a liquid and you have a gas, and they're all finite. All those are objects. Those are things. In fact, if they're made of atoms, they had better be things, because an atom is a thing, so anything made of atoms had also better be a thing, okay? And so solids, liquids, and gases are all things, okay? Okay, but here we have what an object is. In fact, what you just said here, okay? Here's an object, okay? And we'll call that air, just a blob of air. And we've frozen the picture. We took a snapshot of air, and unfortunately it was colorful, so we could see what it looks like. That's what that blob is in one frame of the movie, okay? Now, as you can see, I've got some black stuff around it, but that black stuff, I put a frame around it, but that frame is artificial. The black stuff is not infinite. It's not finite, because it's not an object. It's a concept. Black stuff is nothing. That's what it's known as. And nothing is that which doesn't have shape. But if you want to argue that space is ether, ether is space, and that space is a physical object, or that ether is a physical object, okay, then you got to do the following, which is what he just mentioned, and that's that. You got to tell me what the white stuff is that encapsulates the ether.
Assuming it has shape.
Or shape, yeah. But it's
assuming the ether is finite.
Yeah, if it's finite,
shape, and that means there's something that's around it.
Right, something has to give it contrast. So you got to identify the white stuff, okay? So that's your task. If you cannot if you cannot make a picture of the ether, and you cannot draw something around it and tell me what that white stuff is, you cannot even start your presentation. We're not done with your proposal.
The proposal is usually where all the time goes.
You gotta spend 2,000 years on the assumptions and 5 seconds for your dumb theory. We don't care about that.